Hello out there, welcome to this tutorial. It is matrices and we'll be looking at matrix multiplication in this tutorial. So we'll first look at how matrix multiplication is being carried out. So let's consider matrix M and N where their entries A, B, C, D, E, F, G, H are real numbers. So the matrix multiplication of M and N denoted by Mn is given as Mn. You bring in M first, followed by N. Then the result is AE plus BG, AF plus BH, CE plus DG, and CF plus DH. So note that multiplication of two matrices is the sum of the product of the corresponding elements in the rows of the first matrix and columns in the second matrix. So we will now look at this explanation as it is contained in the solution of the product of M and N. So what they are saying here, the sum of product of corresponding element in the row of the first matrix. So the first matrix, we take the row and the column in the second matrix to get the first element in the resulting matrix. So you see the sum of their product. So A times E, that's AE, plus B times G to give you BG. And when you sum it up, we get the element there. So again, to get this element, it is the first row of the first matrix and the second column of the second matrix to get the second element of the resulting matrix in the first row. So you can see AF plus BH, AF plus BH, and we get that element. So the second row now, we go down to the second row of the first matrix, and to get the first element, we multiply it by the first column of the second matrix to get the first element in the second row of the resulting matrix, which is C times E, CE plus DG plus DG. And that's that. And the second element in the second row is still the second row and the second column. So we get the second element of the second row of the resulting matrix. So we have it as CF plus DH, CF plus DH. That is that. So we now look at conformability of matrix multiplication. Conformability of matrix multiplication. Not all multiplication of matrices are defined. Those that are defined are said to be conformable for matrix multiplication, and those that are not defined are said to be not conformable for matrix multiplication. How do we do this conformability of matrix multiplication to know whether the multiplication is defined or not? So we go. The matrix multiplication of A and B is only defined when number of columns of matrix A is equal to the number of rows of matrix B. So if AB is defined, we say that A and B are conformable for matrix multiplication. In general, if A is of order P by Q and B is of order Q by R, so we say AB is P by Q into Q by R. So this is conformable since the rectangle contains the same letter Q. This rectangle here, this is Q, this is Q. The content, that is the center here, must be equal. The items there must be equal. With that, we said they are conformable. And the order of the resulting matrix will be what? P by R. So that one will now have P number of rows and R number of columns. So we now say BA BA now will be Q by R and P by Q, and this is not conformable since the rectangle contains different letters R and P. So this is not conformable. It means the multiplication of BA is not defined for matrix multiplication. So we take the first problem. In our first problem, we have matrices A and B. We have to find the product of A, B. So what we do is first check the conformability of this matrix multiplication. This is a row matrix. Matrix A is a row matrix. It has only one row and two columns. One row, two columns. And matrix B is a square matrix of order 2 by 2. So it has the same number of rows and columns. So it is of order 2 by 2. So we check for the conformability now. This is 1 by 2. A is 1 by 2 and B is 2 by 2. And we can see now the numbers at the center here are the same. So we have our resulting matrix to be 1 by 2. So 1 by 2 is going to be a row matrix also. So the resulting matrix is of the same type with matrix A. So we now go A multiplied by B. So we pick the row and the column to get the first element. 2 times 2. So that's 2 times 2 plus negative 3 times 1. That's for the first element. So the second element will still be the row and the second column. 2 times 6 plus negative 3 times 3. That's it. We now multiply out. 2 times 2 gives 4 plus negative 3 and 12 plus negative 9. So 12 plus negative 9, 4 plus negative 3. Here plus times negative gives negative, so 4 minus 3 gives 1. 4 minus 3 gives 1. 12 plus negative 9. So plus minus, that's minus. 12 minus 9 gives 3. So that is the resulting matrix for the product of A and B. So we go to problem 2. Let X be given, Y be given. So we have to find XY and YX. And probably we are to check for the commutativity of matrix multiplication here. So this is XY and this is YX. It's not always commutative. So matrix multiplication in general is not commutative. So we'll verify from here. So this matrix X is of order 2 by 2. Matrix Y is of order 2 by 2. So we don't need to check for conformability of these products since there are square matrices of the same order. So the result is going to be a square matrix of the same order. So we start with X multiplying Y. So we have X and we have Y. So we go in the resulting matrix. So to get our first element there, we look at the first row of the first matrix and the first row of the second matrix. So we are going to have it as 4 times 2 to give us 8. 4 times 2 to give us 8 plus 3 times 3 to give us 9. So we have it 8 plus 9. Then to get the second element in the first row, it is still the first row multiplying the second column. So we have the first row multiplying the second column to get the second element of the first row of the resulting matrix. So 4 times negative 5 gives negative 20. That gives negative 20. And plus here 3 times negative 2 gives negative 6. So that one is done. We go to the second row. in the second row of the resultant matrix, the first element there will be the second row here multiplying the first column here. So we'll have it as a negative 1 times 2, which gives negative 2, plus 2 times 3, which gives 6. We are done. And the second element in the second row there will still be the second row here and the second column. So the second row here and the second column. So we'll now have it as negative 1 times negative 5, which gives 5, plus here 2 times negative 2 gives negative 4. We now simplify to get our resulting matrix. So 8 plus 9 gives 17, and negative 20 plus negative 6 gives negative 26. Negative 2 plus 6 gives 4, and 5 plus negative 4 gives 1. So this is the product of x by y. So we go for yx. So y comes first, followed by x. So again, in our resulting matrix, the first row and the first element there will be the first row here and the first column here. So to give us the first element here, so we have 2 times 4 to give us 8, plus negative 5 times negative 1 to give us 5. And that's done. For the second element, we still look at the first row and the second column here. So that will give us the second element here. So we have 2 times 3 to give us 6, plus negative 5 times 2 to give negative 10. We go to the second row. So in the second row, the first element will be the second row here and the first column. So we go. That's going to give us this. So 3 times 4 gives 12, plus negative 2 times 1 gives 2. Negative 2 times 1 gives 2. And for the second element there, it is the second row and the second column to give us the second element here. So we have 3 times 3 to give us 9, plus negative 2 times 2 gives negative 4. So we now simplify to get our resulting matrix. So from here we have 8 plus 5 to give us 13. 6 plus negative 10 gives negative 4. 12 plus 2 gives 14. 9 plus negative 4 gives 5. This is the result of multiplying y by x. So if you compare these xy and yx, you discover that they are not the same. So matrix multiplication in general is not commutative. So we go for problem 3. Here we are going to test for conformability of matrix multiplication. A is of order 2 by 2, so we have a 2 by 2. B is of order 2 by 3, 2 rows, 1, 2, 3 columns. So we have a 2 by 3. So we discover that what we have at the center here are the same. So since they are the same, they are conformable for matrix multiplication, and the resulting matrix will be of order 2 by 3. It's going to be of order 2 by 3. So the same order with matrix B. So we go. We have matrix A. So the A is here, matrix B to follow. Then in the resulting matrix, we are looking at the first element. The first element will be the first row here and the first column here, which is going to give us the element here. That's negative 2 times 4 Negative 2 times 4 gives negative 8 plus, again, we are going to have it as 1 times 2. 1 times 2 gives 2. And we are done there. For the second element, we are going to have the first row and the second column here to give us the second element here. That's going to be negative 2 times negative 1, which gives 2, plus, again, this is going to be 1 times 3. 1 times 3 will give us 3. Then we go to the third element in the first row, which is still the first row and the third column here, to give us the third element in the first row. So we are going to have it as negative 2 times negative 2, which gives 4. That gives 4, plus, again, we have it as 1 times 1. 1 times 1 gives 1. So we are done with the first row, and we go to the second row of the resulting matrix. The first element there will be the second row here and the first column here to give us the first element in the second row. That's going to give us 3 times 4, which is 12, plus 0 times 2, which gives 0. That gives 0. Then we are done there. So to get the second element in the second row, it is still the second row here and the second column here. So we multiply them out, sum them up. So we have to give us this element here is going to be 3 times negative 1, which is negative 3, plus the next one is 0 and 3. 0 times 3 gives 0. Now to get the third element in the second row, it is still the second row here and the third column there. So we have a second row, third column to give us this element here. So we pick 2 and negative 3. 2 times negative 3 gives negative 6. So again, it is 0 and 1. 0 times 1 gives 0. We simplify now. So negative 8 plus 2 gives negative 6. 2 plus 3 gives 5. 4 plus 1 gives 5. 12 plus 0 gives 12. Negative 3 plus 0 gives negative 3. And negative 6 plus 0 gives negative 6. This is the result of multiplying A by B. So we go to the fourth problem. The fourth problem, again, we check for conformability of the product of the two matrices. So Mn, this is 1, 2, 3 rows. M is 3 by 2. 3 rows and 2 columns. So that's 3 by 2. And N is 2 by 2. 2 rows and 2 columns. So 2 by 2. So again, at the center, we have the same number, and the resulting matrix will be 3 by 2. So the resulting matrix will be having 3 rows and 2 columns at the same order as M. So we have M, bringing M, and bringing N. So we multiply out in the resulting matrix. The first element, which is going to take the place of 4 here, is going to be the first row here and the first column here to give us the first element here. So it's going to be 4 times 4, which is 16, plus 2 times 1, which is plus 2. Again, for the second element here, it is the first row here and the second column. That's going to give us 4 times 1 gives 4, and 1 times negative 1 will give us negative 1. So that's going to be 4 plus negative 1. For the second row, this is going to be the second row here The first element there is going to be the second row here and the first column here. So it's going to be negative 2 times 4 gives negative 8. And again, that's going to be 0 and 2. 0 times 2 gives 0. That's plus 0. And for the second element there, is still the second row and the second column here. We have negative 2 and 1. So negative 2 times 1 gives negative 2. And again, we have 0 and negative 1. That's their product will be 0. So plus 0. Lastly, the third row. The third row like this. We have the third row here and the first column to give us the first element in the third row. So we are going to combine 1 and 4. 4 times 1 gives 4. And again, 3 and 2. 3 times 2 gives 6. Now the second element in the third row is going to be third row and second column. That gives the second element in the third row of the resulting matrix. So we combine 1 times 1, which gives 1. Then 3 and negative 1 here. That's 3 times negative 1 gives negative 3. So we simplify. That simplification, 16 plus 2 gives 18. 4 plus negative 1 gives 3. Negative 8 plus 0 gives negative 8. Negative 2 plus 0 gives negative 2. 4 plus 6 gives 10. 1 plus negative 3 gives negative 2. This is the result of multiplying m by n. So by the special grace of God, this is the end of the solution to problem 4. And in turn, that is the end of this tutorial for now. Please remember to subscribe to our YouTube channel, Oninab Resources. Like and share this video. By sharing this video, you'll be reaching out with many people that are having problem solving matrix multiplication, and they would be finding solution by sharing it with them. Thanks for watching. Goodbye till I come your way again. I remain your tutor, Abdurrahman Umar.